Right, for x, if we're looking at this right angle triangle, x is hypotenuse. So we're going to square the other two and add them together. That's why that is a plus. So x is going to be 25. Yes. Then once we have that x is 25, we can put it in there and now we can use that value in our other calculation. So now if we're looking at the middle triangle, we need to find y. Y is not the hypotenuse. So we're going to say hypotenuse squared minus the other one, 7 squared. That's why it's 25 squared minus 7 squared. So that will give you that y is 24. Guys, just for those of you, I think this is probably the first time that you're actually using your calculators for these types of calculations. I just want to show you quickly. For calculating the first one, I suppose you could have done it in your head, but like I said, if it's such big numbers, it will either allow you to use a calculator or it will give you smaller ones. I just want to show you, if you type 20 and now you want to square it, right? There is a button there with an x squared. So you press that button and then it squares it up. Okay. Plus, what was the other one? 15. Again, I want to square it, so I'm going to press on that square button there. That is equal to 625. Alright, now if you don't know what that is, what the square root of that is, you see that square root button with a little block. You're going to press that button. And now, guys, you can either type in 625 or what's very nice about this calculator, thank you, you can press the answer button. That is going to use whatever your answer was from the previous calculation. Alright, so answer. Or like I said, you can type in 625 if you want to. If you now press equals, it will give you the square root of 625. Okay, just in terms of your calculation. For the other one, for getting z, you'll type 26 squared minus 24 squared. That is equal to 100. Square root answer equals 10. So hopefully you guys do know that the square root of 100 is 10, right? But I'm showing you how to use the calculator there. So, that's please, you have to write at least this first line, Pythagoras, and then the answer. Okay? You can get 3 marks for a calculation like this. 1 mark for that line, so for knowing that you take the hypotenuse squared minus the other one squared. 1 mark for your reason, and then 1 mark for actually getting that table. Some of you were getting confused yesterday. Some of you were square rooting multiple times. And if you have, like for this example, thank you, that z squared is 100. Z is going to be the square root of 100, which is 10. And then you stop. You're not going to square root again. Okay, you just square root 1. I did write this on the board yesterday. Just the perimeter of the shape, which I think you might have taken down. If you didn't, please write it down now somewhere. And then also the area of that shape. I'll move across this now, but it is actually there on the board as well. Okay, we're going to copy it down. So we're going to talk more about perimeter today and then possibly getting into area as well. So that you have that space. And onto that can't be square. Oh, onto that can't be square root. Yeah. Then that's like what we did in the previous exercise, we just leave it as a square root. Then I'll show you when we do examples. There's a button on the calculator that you can press that. The area there, just make sure that you have that as well. And then if you, we started off, there it is an exercise, number 2. Any questions, guys, on that one? Okay. Okay, there we go. There is the reduction exercise. Add it up. Two people left. Right, so what now on number 2, x and y, both of these sides were not the hypotenuse, right? So I'm looking at triangle ABD, which side is the hypotenuse? This one, okay, AB or 4B, yes. So the 20 units one, all right? The one that's opposite the 90-degree angle. That's why I took 20 squared minus the other one. Minus 12 squared. Always hypotenuse minus the other one. And then when you're finding y, you have to work in triangle ACD, this one. So now here the hypotenuse is 15. So for that one, you're going to do 15 squared minus 12 squared with y. Has any questions on Pythagoras in general? We are kind of moving away from it now. It might still come up in a question here or there. We have to use it. But yeah, basically you need to be able to calculate the hypotenuse by adding, or a side that's not the hypotenuse by minus. Okay, those are the few things in the Pythagoras course. All right, guys, we are moving on to perimeter now. And some of you might have done questions that look just like this. Some of you might know exactly what to do here. I just want to make sure that we all are on the same wavelength. Basically, we all know what's going on. So perimeter is the new heading. Just going to make this picture a little bit bigger. Yeah. We need it now. All right, guys, we did speak about perimeter yesterday, right? And we did say there, you can just add here kind of next to your heading, that to find the perimeter, you have to add all the sides that go around the shape, on the outside of the shape. All right, so add all sides. We can just add that real quickly, and then I'll move down again. Now, the important thing, guys, with perimeter and with area as well, which we're still getting to, is that you have to have all your units, or all your sides have to be in the same units. So what I mean by that, you see now when we do the first example, you can't work with centimeters and millimeters at the same time. All right, we have to have all our sides expressed using the same unit. So we are going to practice that now in number 1. And then if you can please draw that picture, it doesn't have to be perfect, all right? Basically a triangle on top of a rectangle. So that's 3 centimeters, 3 centimeters, 4 centimeters at the bottom, and then 60 millimeters. Yeah. You don't have to draw the scale, just do the shape and pull in the value. It's fine. Okay. Now guys, do we notice that all of these sides are not expressed or written using the same unit? Yes. Right, we have a problem here. This one, the 60 millimeters, is written in millimeters, and all the others in centimeters. So we need to convert that one to centimeters as well. So guys, just here next to this, I'm going to make a little star, and I'm going to write a note, convert 60 millimeters to centimeters. So you have to have all five that you're going to work with the same unit. Yes. So you can do it. The thing is, if it's not centimeters, then you will convert three others to measurements. More. Okay, so guys, here's the part of least resistance, I think. All right. Don't convert all of these to millimeters because that's going to be more work than just converting 1 millimeter to centimeters. Okay. But sometimes in the question they say, give your answer in centimeters. Then they're telling you what you must work with. Okay. Or they might say, give your answer in millimeters. Then you have to convert all of them to millimeters. Okay. But if they don't say, you can choose, and you can choose the one that is the least amount of work. All right. Now, do we know how many centimeters 60 millimeters is going to be? It's 6 centimeters, right? You can see that one on your ruler. That's the easiest one to work with. 1 centimeter is 10 millimeters. Okay, or you can just put in brackets here. 10 millimeters is always equal to 1 centimeter. Okay, now, do we have all the sides of this shape? We have to find the perimeter, right? So we must add all the sides together. I have that one, that one, that one, that one. What about this one? Then 60 millimeters or 6 centimeters wide. Because it looks like it. Alright. What type of shape do I have here? Yes. It's the rectangle, hey? So guys, on your picture, please, either using a pencil or using a different or using a different color pen. Please just draw a line here. You can do a dotted line as well. Draw a line there. This is actually this full shape consists of a rectangle and a triangle at the top. What did you want to say? We always, if we have a complicated shape, we split it up into easier shapes, all right? Shapes that we are familiar with. So that is a triangle there at the top, and we have a rectangle. So guys, because of that, this is also going to be 6 centimeters, correct? Did they tell us that though? We knew that because it's opposite sides of a rectangle. So guys, unfortunately, we have to write that down. Okay? We need to write that as a reason. Okay, so remember with geometry, this also counts as geometry and shape. Reasons are very important. Okay, so we're gonna have to get into basically writing the reason for almost everything that we do. Okay, a bit of an adjustment. But that's fine. Now we're gonna say perimeter is equal to 3 plus 3, so those two top sides. But these are right 3 centimeters plus 3 centimeters plus 6 centimeters. You're just going to put your units in your answer. Okay, when you're calculating, you can just write the numbers. So 3 plus 3 plus 6 plus that bottom one, which is 4, plus another 6. Now, next to that, guys, next to that other 6, we have to write opposite sides of the rectangle. Okay, which you might not think of. That's like a reason thing. So just next to the calculation, sorry that I'm moving across now, we have to write the reason opposite sides of a rectangle. I just don't have enough space there because there's something else on the side, but you can write it all in one line. Okay. Guys, we are going to do quants again later in the year, and then we'll talk more about the different types of quants, and I'll give it to you, the ones you know already, right? Rectangles, squares. So now we can add all of that together. What's that? 3 plus 3 is 6. Plus another 6 is 12. Plus 4 is 16. Plus 6 is 22. 22, and now very important, centimeters. There you put your units. Okay, don't write units in your actual calculation. That's going to take so long. Alright, so you just have to put it in your answer. Any questions on that one? Okay, next one, number 2. I'm going to do this rather. I'm going to just draw that picture for me again, please. You must be quick with this. 4.5 centimeters. Okay, guys, we have all 3 sides here, hey? So this is actually a more simple one, but what is the problem here? The 60 millimeters again. Sorry now that it worked out that it's the exact same measurement. Alright, but we see that there is one side is given in millimeters, so we need to work with centimeters. Okay. Again, just because the other 2 are written in centimeters, I'm only going to change one instead of changing both of those to millimeters. Right? So, perimeter. I'm going to show you now a quick way of writing this down. Perimeter is equal to 3 plus 4.5 plus, and I'm going to write 60. Now I'm going to write 6. And you don't actually have to do that conversion in a separate calculation. You can just do it in your sum when you're adding them together. Guys, I'm just going to add here as a little arrow, just a reminder where that is coming from. 60 millimeters is equal to 6 centimeters. So just add that so that when you look back at this example, you don't ask yourself where does the 60 go? Or where does that 6 come from? Okay, just because we did that conversion. Okay, what is that total? 3 plus 6 is? 9 plus 4.5 is 13,5. No, we don't have to write the reason for this because all the sides were actually given. Okay, it's just that in the previous one, we have to know that that one was 6 because of the reason. Okay. Okay, any questions there, guys? Number 3. Now, if you don't have a compass here to draw a circle, just see if you can get like different or something. Sorry. That is a diameter. Oh, no, sorry, it's a radius. Sorry, it's not the diameter. Radius. Yeah. All right, I'm going. It's happening. The answer of this question. All right, guys, number 3. Now this is a circle. Now we don't actually say that a circle has a perimeter. Okay, it has a different word. Does anyone know what that is? Circumference. So just write here perimeter. The perimeter of a circle is actually the circumference. All right, we just use that word for circle, right? Circumference circle. So guys, if they're asking you for the circumference, you need to know what they're asking. Okay. Now this one is a bit tricky because we don't have sides that we can add together. Right? The circumference here is actually the length of this. If you can kind of imagine, say you made a circle up out of a piece of string, right? Or if you lay a piece of string down, going all the way around the circle, you could then like stretch the piece of string out and measure it. That would be the circumference. Yeah. Radius is that. Yes. Now that's for circumference in specific formula that you're gonna have to memorize because I mean there's nothing they actually telling you what that length all around the circle. Okay, so the formula that you might know already, if not, you're gonna have to memorize it. There are actually two formulas, all right? Pi times d diameter x or the circumference is 2 pi times radius. So that we need to actually figure out, do we know what a radius and what a diameter is? This is the center. That is the center of the circle, right? From the center of the circle to any point on the circle, on the circumference, right, on that outer edge of the circle, that is a radius. That is the radius. So in this case, this circle has a radius of 55 millimeters. Okay. Now, how do you use the radius to get the diameter? Let's just quickly remember the diameter is a line from one point on the circle going through the center to the other side of the circle, right? To another point on the side. So guys, the diameter is actually 2 times the radius. Okay, so let's write that down somewhere, maybe just underneath the circle. Just write diameter. Yeah. So guys, are we understanding that these two formulas are actually the same thing? The diameter is 2 times the radius. Do you see that? So here we have pi times the diameter. Here we have pi times 2 times the radius, which is the diameter. Okay, so this formula is actually just two different ways of writing the exact same thing. Alright, so either, it now depends, did they give us the radius or did they give us the diameter? They gave us the radius, hey? So I'm going to use this formula. Okay, if they gave us the diameter, we'll use the first formula. Okay, it depends on what they're giving us. So we're going to say the circumference is 2 pi. You can write it just like that. And then you can either write times 35 or you can put in brackets 35. Okay, you can write it like this as well. 2 pi and then in brackets 35 like that. It's up to you. So pi is a number that just carries on forever. Alright. Some people use 3.14, some people use 3.142, some people use 22/7. But, and guys, this is now something that you will have to use your calculator for. On the calculator, there is a pi button. Right? If you have a different one, it might be in a different spot, but if you have a fancy calculator, above the times 10 to the x button, there is a pi there. Yeah. So what we're going to do is we're going to press 2, and then, guys, if I now press this button, is it going to be pi? No. So I have to press shift, and then that button, and then it is pi. So we don't even have to worry about what number pi is, guys. The calculator has it stored, and it's going to work with it. Okay. So whenever you're working with pi, you will have to use your calculator. Times 35 equals 70 pi. Now we can write 70 pi for now. But guys, what does that actually mean? We don't really know what that means, right? That's not really understandable. So they often say you must write your answers in decimals rather. So do we see that SD button there? Press that one. There we are now going to get a decimal answer. So 219, let's round it to two decimals, 91. 219,91. And what was the unit that we worked with? Millimeters. Then I have to convert this millimeters to centimeters now. No, there are no other measurements. Okay, so you don't, it's only if you have different measurements that you must convert one of them. Okay, final that one, guys. And I go to the next one. Yes, ma'am. There we go, number 4. Go there. Sorry, I'm taking off the way down. Guys, it doesn't have to even really look like this, hey? You make it one line too long, then don't worry, hey? No way. So that's what I'm saying is don't worry if the scale is a little bit out of line, doesn't matter. Just make sure you have all those sides there and that your neighbors are full. Not this exact question, but yeah, you will be placing on this one. Now you have to know. Sorry. And we have all same unit thing. Do we? What about the millimeters of the millimeters? I'm asking all of these I don't think you would say that. Okay, so convert those two, guys. 2 millimeters. Let's convert to big. So these two. Those two. And then you can work out what that perimeter is for me as well. You should be able to. Alright. So, oh, there. I didn't even see that. Yes. Yeah, you will have to give a reason for that, correct? What do you think? No, I'm asking you. What do you think? They said. Then right, that's kind of. Yeah. Yes. All right. No, I'm not done. Oh, you're not done. Okay, we'll wait for you. All right, guys, 70 millimeters equal to how many centimeters? 7 foot and 45? 45. Good. Then, do we know that is what is it going to be? Good. Okay, so my point is yeah, I just don't have space. All right, so then, it's no, any questions? Okay, you're gonna do an exercise now. Sorry, I actually did think it was frozen. My apologies. My bad. Sorry. Here we go. Yeah, I'm ready to get. You're gonna do an exercise. Let me check. Okay, guys, I'm gonna give you an exercise now. Are we fine with that one? Can I take over? Yes, ma'am. Oh, wait. Thank you. Oh, no, I'm done. Your Wi-Fi will be Thursday. What they are telling you guys, that's 1, that's 2, and that's 3. Okay? You have to find the perimeter of each of the shapes and see the remaining left shape will always hold the head. All right. and 95 extras. Right, so this one here, I think, what is it? Converting, hey?
Yeah.
They already were saying that you guys are converting. I don't know if you guys think that you're not allowed to work in those can. When we get our answer, okay. Yeah, so do that quickly, guys. We're also going to mark it now. It's not the end of the lesson. I'm getting there. I'm getting there. Go sit down. I'm going to bring it to you. You didn't have to write injuries for the time because all the time were given, right? All you did was you converted the one and then you added them together. Right, that's all. For the next one, number 2, for this one you did have to give a reason, right? Because they didn't give us all the sides in this case. We gave us 2 of them. They told us that it's a rectangle. So that means that we must know that these 2 sides are equal, right? So that's the second side comes well, and those 2 sides are equal, so that's the second comes from. But you don't have to write the reason why. Okay, it's the same reason for both of those things. Because the sides of one, opposite sides of rectangle, and that's fine. Now I said you do it incorrectly. And so it takes me. Okay, guys, number 3. There we go, number 3, 41. So you have to convert those. Okay, give me 1 second. I'm just checking quickly what. Yeah. Okay, guys, give you some more work to now. Please take notes of this. Just down the 65 now, right? Looking at these 2 that are listed here. And it's important that you follow the instructions that they are saying there. Perfect. Not good, right? Mine. Alright, guys, that's the exercise. Rows on two it's not a lot, guys. It's really not a lot because finish an hour and a paper is a bit late and then there's not hard work on the reason. Alright, so let's get that done. You are already doing number one and two is obviously further second one. Okay, please. Read the instructions. 193, and then on the revision exercise of that same chapter, guys, you do it in 4 and 5 only. Those questions on good circle, we just practice circle cut now, hey? We did an example, so the rest you must see through. So there are no circles in the exercise. 1, 2, backwards. Alright, let's go. And if you don't have a book here, fine. So what I does, take it to the data and do it.